Imagine being deep beneath the ocean's surface, surrounded by darkness, with thousands of tons of water pressing in from all sides. Now imagine that your only way back to the surface depends on nothing but air, water, and a bit of physics. How does a submarine, a massive steel vessel, disappear beneath the waves and then rise again with precision? It's not magic, it's engineering at its finest. A submarine's ability to dive and surface is all about controlling buoyancy. To understand this, think of an empty plastic bottle floating in water. If you fill it with air, it stays on the surface. But if you squeeze the bottle, forcing some of the air out, it starts to sink. Submarines work the same way, except instead of squeezing a bottle, they use large tanks called ballast tanks. When the submarine is at the surface, these tanks are filled with air, making it lighter than the water around it. But when it's time to dive, the crew opens special valves, allowing seawater to flood into the ballast tanks, pushing out the air. Water is much heavier than air, so as the tanks fill, the submarine becomes denser than the surrounding water and begins to sink. But it doesn't just drop straight down. The submarine has hydroplanes, which are like small fins on the sides. By tilting these fins, the crew can control the angle of descent, ensuring the submarine glides smoothly into the depths, rather than plunging uncontrollably. Once it reaches the desired depth, it needs to stay there without sinking further or floating back up. This is done using trimmed tanks, smaller tanks that adjust the submarine's buoyancy with precise amounts of water and air. When balanced just right, the submarine can hover, moving stealthily beneath the waves. When it's time to surface, the process is reversed. High-pressure air is forced into the ballast tanks, pushing the seawater out. As the tanks fill with air, the submarine becomes lighter and begins to rise. Again, the hydroplanes help control the angle, ensuring a smooth, controlled ascent rather than an uncontrolled rush to the surface. This entire system requires expert handling. Too much water in the tanks and the submarine could sink too deep, too little, and it may struggle to stay submerged. That's why submariners go through extensive training to master the balance of buoyancy and control. Submarines use this diving and surfacing ability for many purposes. Military submarines rely on stealth to move undetected beneath enemy waters. Research submarines explore the deep ocean, reaching places no human could survive unprotected. Famous submarines like Alvin have explored deep-sea trenches, uncovering secrets of the ocean floor. To see this principle in action, try this simple experiment at home. Take a plastic bottle, partly fill it with water, seal the cap, and place it in a tub. Watch how it floats at first. Now, slowly squeeze the bottle or add more water inside. As air is pushed out and replaced with water, the bottle sinks, just like a submarine. So the next time you see a submarine disappearing beneath the waves, you'll know exactly how it works. But here's something to think about. If you had to design your own underwater vehicle, what features would you add to make it dive and surface even more efficiently?
Got a question about how something really works? Drop it in the comments and we might cover your topic in our next video.